Today I wanted to run through some equations of lines. So equations of lines are actually quite useful in real life. Anything that involves a rate of change. So if I'm gaining 2 inches of snow per hour, or if I'm losing a certain amount of water out of a bucket per minute, these all use rates of change. And so we can plot these on a graph. So the first example I have for you is a small college in Indiana charges $9,600 for tuition in 2010. On average, each year, the school increases their tuition by $800. Draw a graph to represent this situation and label the axes. How much will it cost in the year 2025? When do you think the tuition will be $15,000 a year? And do you think the tuition will continue to increase indefinitely? So I wanted to show you some real-life examples, as we call them, so you can understand why we learn equations of lines in pre-algebra and algebra. So in this situation, in the year 2000, it cost $9,600. So this is our starting amount. Okay, and that's going to be what we call the y-intercept. Okay, and every single year it raises tuition by $800. So I'm going to go up 800 and over 1. So down here I'm going to have after 1 year, after 2 years, after 3 years, and so on. But I want to be kind of careful with that. So in this problem, I am saying after 2010. So I need to do a let statement. I need to say let x equal the number of years after 2010. So that makes sense that at our y-intercept, that is actually a point. It's at time 0, we had a y value of 9,600. Okay, so this is time 0, this is time 1, time 2, time 3, and so on. So if we go up by $800, then if I add 800 to 9,600, I get $10,400. And it continues, so I'm still going to go up and over and up and over and up and over, and I'm going to get this line. So I have all of these points, and it creates this line. Now this line would go in both directions, so even though I called that my starting point, my y-intercept, I could go in the opposite direction as well. So I could have a time of -1, -2, and so on. And in the context of this problem, that means -1 would be the year 2009, -2 would be the year 2008, and so on. So we can come up with the equation of the line, which means that we start with the $9,600, and after every single year we gain $800. So it's going to look like this. We're going to have 800x plus 9,600. And you can check with a T-table. If you plug in x equals 0, so right here, if we put in x equals 0, we get 800 times 0 plus 9,600 gets $9,600. And if we plug in time 1, then we're adding 800 to it. So if we add 800, we're getting $10,400. And you can continue to add. If I add 2, I get 11. 800 would be $200 there. So the question is, do you think that the tuition will continue to increase indefinitely? So personally, I do not think it would continue indefinitely, because that means that we could at some point have tuition that's $1 billion a year. Hopefully that's not the case. But then there are other questions, like how much will it cost in the year 2025? Well, that doesn't mean that I plug in 2025 for y. It actually means that I put the 2025 for x. But it's not exactly 2025. Remember, we let x be the number of years after the year 2000. So 2025 would be plugging in 15. So if we plugged in x equals, instead of 0, we plugged in 15 here, we would get our answer. So, and then it says, when do you think the tuition will be $15,000 a year? Well, that would be plugging in y is 15,000. And then we would solve for our x value. So if I had 15,000 equals 800x plus 9,600, I solve that just like I solve a regular algebra equation. So I'm not going to waste time and do that, but I just wanted to give you this basis for lines. So lines don't always have what we call a positive slope. So in this case, we had a positive slope because as I read it like a book from left to right, my line went up. Okay. So sometimes we have negative slopes, and this next one's an example of a negative slope. So in this one, it says a bucket holds 7,000 milliliters of water. Unfortunately, there's a hole in the bottom of the bucket. Every second, the bucket loses 200 milliliters of water. Draw a graph to represent this situation and label the axes. So if I'm doing that, I start out with 7,000 milliliters. I go down 200 and over 1. So clearly this isn't drawn the scale because my 200 kind of looks like 1. But these are units of 200, and these are going to be units of 1, 2, 3, and so on. So that's why we label our axes, because sometimes we don't draw things so it looks like 7,000 tick marks. So as I go down to 200 and over 1, this is in seconds. So I made an error on the first one because I didn't label. So this should be number of seconds. And this one should be the number of milliliters in the bucket. So number of milliliters of water. So as we do this, we start to see that we get different values. So I have the point 0, 7,000. If I subtract out 200 milliliters, I'm going to have 1, 6,800. And I'm going to have 2, 6,600, and so on. So I keep getting all of these points. And so we see that this bucket is losing water. So it says, will the line continue? So it says, when will the bucket be empty? We would be trying to find this point right here. So if we're trying to find that point right there, we don't know the x value. But we do know the y value. So if you think about the y values, this was 7,000, this was 6,800, 6,600, and so on. So we have a bit of a pattern. But sometimes these graphs are kind of cut off at the end, and we can't really guess, because this might only show part of it. So we got to plug it in. We got to come up with an equation. So we do. So we say, well, I started out with 7,000, and every time x increased, I lost 200. So I have negative 200x plus 7,000. So this is in the form y equals mx plus b, where m is what we call the slope. So in our case, we lost 200 milliliters per 1 second, so every 1 second. And our b is our y-intercept. So I sometimes call that the starting point because of these real-life problems, right? So in this case, this was 7,000. So really, this portion of the line is gone because our bucket was kind of filled on, I'm assuming it was filled to the top. Maybe we didn't have a giant bucket, but if it was filled to the top with 7,000 milliliters, we can't have any more than that. It would be spilling over the sides, right? And we also kind of removed this portion here. So it doesn't continue indefinitely, because once the bucket's empty, you can't have negative amounts of water. That's not how this situation works. But we use this line to kind of approximate different values. All right, so let's talk about lines in general. So usually in algebra, we start out with check to see if each point is on a given line. We start checking kind of T-tables. Okay, so what we're saying is that if I plug in an x value of -1, do I get a y value of 7? And unfortunately, sometimes these ones have more than one answer, and these ones actually do have more than one answer. So we have to go through all the choices. So if I have -1, 7, and I plug in for x and y into the equation 3x plus y equals 3x plus 4, I'm going to have 7 is equal to 3 times -1 plus 4. So a lot of times I put like a little question mark over the equation because I'm seeing if this is true. So if I have -3 plus 4, unfortunately that's 1. So this is not actually true. So this one doesn't work. So just kind of cross them out as you go. Now the point 1, 7, that one does work because this would be 7 equals 3 times 1 plus 4. So 7 is equal to 7. So that one was good. 0, 4, I think you can start to see some of these as you think about plugging them in. I have 0 for the x, 4 for the y. This one does work because I get 4 equals 4, right? So as I'm checking, I'm going to put in a question, and then if I get to the end, I can check it. So unfortunately, you have to do all of these. So make sure you're checking all of them. But the next one, I think you can see pretty quickly it doesn't work. So if I have the y value of 2 and 3 times 10 plus 4, I get 2 is equal to 34. Well, that doesn't work. So this one, when I was questioning it, I went through, I got 2 is equal to 34, so this one's out. Okay, and that's what we do for all of these. So we plug in. So for A, if I plug in 5, 0, this is, again, the x and the y. So if I have 2 times 5 minus 5 times 0. I'm seeing if that's equal to 10. I do get 10 is equal to 10, so that one works. Okay, the next one, if I plug in 2 comma 0, I have 2 times 2 minus 5 times 0. Okay, that is not equal to 10. And you can check, that's 4 is not equal to 10, so that does not work. So you can put the little question mark above, or if you start to see it's not working, I just kind of cross it out. All right, the next one, 0 comma negative 2. See if you can do that one kind of in your head. If you plug in a 0 here and a negative 2 here, do you see how we would have 0 minus 5 times negative 2 is equal to 10? So we do get positive 10 is equal to 10, positive 10, right? So it works. Do another color for this one. So if I plug in 20 for x and 6 for y, this one's big numbers, but just because they're big numbers, don't assume that it doesn't work. So in this, I get 40 minus 30, and that is indeed 10. So that one works as well. So this one had 3 solutions that worked. Okay, the last type is kind of the hardest one because we have the x and y on opposite sides, and we have other numbers too. So we just kind of have to do it very carefully. So if I plug in negative 2 on the first one, I get 4 times negative 2 minus 6. And then I'm seeing if that's 3 times the y value is negative 5 plus 1. Okay, so I'm checking to see if these are true. So I get negative 8 minus 6 is negative 15 plus 1. So I get negative 14 is equal to negative 14. So that one worked. So just kind of go through there and check each one. I'll do the 0 ones next. So if I did C, if I plug in 0 for x, I get negative 6 on the left side. And if I plug in 1 for y, I get 3 plus 1. So negative 6 is not equal to 4. That one's pretty easy to eliminate. And then this one, if I plug in 5, 4 times 5 minus 6 is equal to 3 times 0 plus 1. So this is 20 minus 6 is 14. Is not equal to 1, so that one's a pretty easy one to check as well. So the last one we have to check is B. So I have 4 times 1 minus 6. I'm seeing if that's equal to 3 times negative 1 plus 1. So I get 4 minus 6 is negative 2. I want to see if that's negative 3 plus 1. So it is. So negative 2 is equal to negative 2. So that one did work. So on number 1, we had B and C that worked. On 2, we had A, C, and D. On number 3, we had A and B. All right, so let's get to the more interesting things. Checking to see if the point's on a given line, that's not very exciting. But how about these ones? So if I'm graphing each line. So on number 1, I have the line y is equal to 3x minus 1. So if we think back to those problems that we did with the tuition and the water dripping from the bucket, I think you started to see a pattern. Okay, so this 3 is our slope, and this negative 1 is our y-intercept. Oops. So the y-intercept is always where we're going to start. And it's a point. Okay, and it's along the y-axis, this axis right here. So this point is the point 0, comma, negative 1. So we're starting down here at negative 1. And the slope is 3. Well, we always think about the slope as being a fraction that is always rise over run. So you've probably heard your teacher talk about this. So rise is how much we're going up or down, and run is how much we're going right or left. Okay, the big thing to know is that if your slope is positive, we go upwards when we're reading like a book, like reading across the page from the left to the right. And if your line goes downwards, this is a negative slope. Okay, it's decreasing. So in this case, we have a slope of 3, which is the number 3 over 1. So it means we're going to go up 1, 2, 3 over 1. So once we have that, we can connect those 2 points, or some people like to do it more than one time. So if I go 1, 2, 3 over 1, I get another point. Or if I even wanted to go down 3, 1, 2, 3, I could go to the left 1 because that still creates this positive slope. It's still going upwards when we read like a book left to right. 1, 2, 3 over 1. Okay, so you don't have to do a whole bunch of points. Really, once you have 2 points, you can draw on the line. So the next one has a slope of -3/2 and a y-intercept of 6. So I'm going to write that as 0, 6. So I'm going to start at 6, and this time my rise is -3. What does that mean to have a rise of -3 and a run of 2? So it means I'm going to go down 3 and to the right 2. And the big thing to notice is that this is a negative. So it doesn't matter if you go up or down. Like I could have gone up 3 and left 2. That's the same thing, because in the end, I would have this negative slope. Okay, so just kind of check that as you're going. If you have a negative slope, make sure it goes downwards. So if I have 0, 6 and I go down 1, 2, 3 over 1, 2, I get there. Down 1, 2, 3 over 1, 2, right there. And then I can graph the line. Okay. The next ones we have 2x plus 3y equals 12. So this is a special type of line. So it's no longer in this form y equals mx+b, which we call slope-intercept form. And this was the easiest one for students. They like this form because they know, oh, okay, I have my starting point, and then I go from to find another point using the slope. This one is not in that form. Now you can get them in this form, or you can do something else in the situation. So on the last ones, I could have done a t-table, right? So if I wanted to do a t-table for the first one, I could plug in different values for x, and I could get points. So if I plug in 0, I get -1. So do you see what I'm doing here? If I plug in 0, I get 3 times 0 minus 1, which gives me a -1 for the y value. All right, so I could also plug in, 1. If I plug in 1, I get 3 times 1. 3 times 1 is 3, minus 1 is 2. So if I plug in 1, I get 2. And you can plug in other things. If I plug in -1 or 2 or whatever, I get these different points. So if I plug in 2, I get 6. 6 minus 1, which is 5. And you can check all of these points are on the line. This was the point 0, -1. This was the point 1, 2. This was the point 2, 5. And I could even plug in strange things. Like I could plug in 1/3. I don't know. If I plug in 1/3, I get 3 times 1/3 is 1, minus 1, I get 0. So at 1/3, I'd be at 0. That's that point that's right there on the axis, the x-axis. So never forget that you can always do a t-table on equations of lines if you get stuck. So if you wanted to, you could do a t-table on something like this. Okay, and you could plug in weird things. Like you could plug in 2 or 3 or whatever for x. But if you plug in some numbers, like if I plugged in a 2, I would then have to solve this equation. And sometimes it's not very nice because 2 times 2 plus 3y is equal to 12 gives me 4 plus 3y equals 12. And this is not going to be pretty for me because when I subtract 4, I get 3y equals 8. And y is 8/3. So it's like, ew, I don't want 2, 8/3. How do I graph that point? Okay, so we're going to pick the easy ones. So let's get rid of all this junk. And we're going to plug in 0 for x, and we're going to plug in 0 for y. Okay, not together. These are two separate points. But if I plug in 0 for x, it's a special point for me. So I end up getting 3y is equal to 12. I get y is equal to 4. So that means when I plugged in 0 for the x value, I got a 4 for the y. Okay, that's what we call the y-intercept because it's this point right here. It's along the y-axis. Okay, we like that point. Okay, and we do the same thing for this other 0. So if I plug in 0 for y, then I have 2 times x plus 3 times 0 equals 12. So I get 2x equals 12. So I get x equals 6. So that's another important point. That's what we call an x-intercept because it crosses the x-axis. And remember, we only need 2 points to draw a line, so once you have those 2 points, we're good. We just sketch in our line, and we're done. So that's the easiest way to graph things that are in that form. Now, you could solve them for y, and sometimes teachers ask that you do that. So when I say solve it for y, I mean get it in y equals mx+b form. So we'll talk about that in a second. So in number 4, if I have 5x minus 2y equals 10, let's do the same thing. But I did a lot of writing here, and I'm lazy, and sometimes I don't want to do all that writing. It's probably good on things like tests to do the writing, you know, because then you're getting points for your work. But I'm going to show you a little trick that my students tend to like. So you're going to take your finger, and I don't have a way to show my finger here on the board, but I'm going to cover up my x values. So imagine that's my finger covering that up. See how I get this equation, negative 2y equals 10? Right away I can see that when I plugged in 0 for x, I got to this equation, negative 2y is equal to 10. Well, that means y is equal to negative 5. So in other words, that's the point, 0 for x, negative 5 for y. So now the question is, what if I plug in, I need to get rid of this. My eraser's huge. I gotta fix my eraser. So if I get rid of that, see, it's gonna be, oh, there it goes. Okay. So if I cover up this one, I now get 5x is equal to 10. Well, what did I do there? I plugged in 0 for the y value. I covered it up, right? So I got 5x is equal to 10, which is x is equal to 2. And a lot of times students are able to kind of do that step in their head. They're able to kind of cover it up and say, oh, 5x equals 10, x is equal to 2 then. Like, you don't have to write anything then. But at least write these 2 points. Oops. So write these 2 points here. That's the important part. So I have 0, negative 5, and I have 2, 0, and once I do that, I get this line right here. Okay, so I told you that sometimes teachers will ask you to solve for y, or sometimes it will say write in slope-intercept form. So if you see either of those instructions, we know what we're going to do. So let's go back up. So we saw we had the equation 2x plus 3y is equal to 12. Okay, so this is just like solving equations. We're trying to get this y all by itself. Okay, so first we have to subtract the 2x from both sides of the equation. Now notice these are not like terms, so don't get tricked and write 10x, right? We can't do 12 minus 2x and call that 10x. That's not correct. Okay, so we're going to write it with the x first, negative 2x plus 12, or you could write 12 minus 2x. Okay, we got rid of the x's on that side. We now have 3y. So this is saying 3 times a number, right? So if I want to get rid of the 3, I got to divide it out because I'm doing the opposite operation. So I now have y is equal to negative 2/3 x plus 12. Okay, that was kind of sneaky what I did there. So let's kind of think about that. This is really the same as saying 1/3 of the quantity, negative 2x plus 12. When I write it this way, students remember, oh yeah, I'm going to distribute this in. Well, the same thing's happening here. This 3 is going into both of these. It's getting distributed to both. Okay, sometimes I draw a cheesy heart. So if you ever see me draw this cheesy heart, it means that that 3 goes into both of them. Okay, so I wrote it as negative 2/3 x plus, oh, I made a mistake, didn't I? It's not plus 12, it's plus, I made a mistake. I was already moving on to my next part of my problem. It's plus 4 there because it's 12 over 3. All right, so last thing, horizontal and vertical lines. Let's do those. So if I have y equals 2, these are the easiest ones. These are easy points if you ever have this on a test. Because if y is equal to 2, let's think about a t-table. It's like, well, if I plug in x equals 0, 1, 2, negative 1, negative 2, well, I don't have any x values. So if I plug in x equals 0, there is no x value, so I guess I still get y equals 2. If I plug in 1, I still have 2, 2, 2. So basically this is every point with a y value of 2. Okay, so every single point with a y value of 2. So I have the point 0, 2. I have the point 1, 2, 2, 2, negative 1, 2, negative 2, 2. I have any point with a y value of 2. I could have pi, 2. I could have 7, 2. Anything that I want. So it creates a horizontal line. So when you have a y equals a number equation, this is a horizontal line. And the reason is because it has every single point that has a y value of 2. So the same logic applies for this. So no matter what y value I have an x value of -3. So it means I have the point -3, 0, -3, 1, -3, 2, -3, 3, -3, -6. I mean, I have all of these. So if I check, I'm going to have -3, 0, -3, 1, -3, 2. And as I start to fill in all these points on this line, I see that this is a vertical line. So an x equals a number is always a vertical line. So just think about it. Think about different points that would be on your line. If I had x equals 7, then that would be every single x value of 7. So 7, 0, 7, 1, 7, 8, right? These are all points that would be on that line. Okay, so good luck with lines. That's all I have for you. Good night.